Okay, so we're looking at the first Agile Mind lesson of the year. This is topic 2. We're going to be talking about how to invert functions. If you don't remember how or what the definition of a function is, we will also review that. So we'll start by looking at an example where an automobile is driving at a set speed in miles per hour, and when said automobile hits this line, the driver hits the brakes and the car skids. So the question is there a relationship between the length of these skid marks and the speed of the automobile? So look at the animation here. So they found that if the car was going 10 miles an hour and the wheels locked up, then the skid mark would be 4.76 feet. If the car was going 20 miles an hour, the length of the skid mark was 19 feet. So here the graph has been populated with data. This is the speed axis. The x-axis corresponds with the speed of the car, and the y-axis is the length of the skid mark in feet. You can see that as the speed of the car increases, so does the length of the skid marks. So does this look familiar to you, this type of function? Okay, so this is a quadratic function. Quadratic function is any function that has x squared. This is the vertex form. This is the standard form. So if a police officer is looking to figure out how fast a car was going when it hit the brakes, like during an accident investigation, they don't know what the speed of the car was, but they may have the length of the skid mark. So we saw that it was easy to plot the length of the skid mark as a function of the speed of the car. Can you use this information to get the opposite? Starting with the length of the skid mark and figuring out the speed of the car. What the animation is showing you is that if you flip the axes and switch the information from the x-axis to the y-axis and vice versa, then you have the inverse function. If you were to plot them both on the same graph, you would find that they were reflections across this line y equals x. So here they've made this abundantly clear. This graph is going from speed to the length of the skid mark, and this one is going from the length of the skid mark to the speed, The only difference is what is considered the dependent variable and what is considered the independent variable. So if this defines a relation, then this is its inverse. If you were to compose these two functions, one function would undo the action of the other, which I'll review on the board. So we'll look at a function that represents the payment plan for a cell phone. Suppose you had a cell phone that was $10 a month plus 7 cents per minute. We're going to use the variable m for minutes and t for total monthly bill. So it should be easy to tabulate that. For instance, if you talked for 0 minutes, it would be $10. If you talked for 1 minute, it would be $10.07. We want to produce an equation that represents this relationship. I'm not going to do this here because you're going to do it on your student activity sheet. But use m for minutes and t for total bill and produce an equation using these elements to represent the dollars of the bill as a function of the minutes.